Hi, good afternoon. My name is Nick Thorne, and I'm going to be presenting a session on that is a follow-on from my colleague Remy Scott's session on SSHing into Tacc systems and what to do once you've arrived on a Tacc login node. I am a system administrator working in the LSS group, and I've been at Tacc for about 6 years. Just a little bit of my background. So let's get right into it. Things that you might want to do once you arrive on a Tacc login node. And what are login nodes for? Okay, so this is some of the output that you're going to see if you followed on from one of the previous talks, as I mentioned, by my colleague Remy Scott, about SSHing in. This is kind of the expectation that you get from the login node, and we're presenting you with a little bit of information, or depending on your exposure to high-performance computing, perhaps a lot of information. Almost everything that I'm going to say today is already available in the user guides, and I'll probably reference them from time to time. But with my own user account, I've now SSH'd to Stampede 2. If you have allocations on other Tacc systems, others will look very similar to this one. But Stampede 2 is just a convenient example. I happen to have arrived on the 4th login node. There's a pool of public login nodes. Should be a fairly substantial selection of other people who are on this node and are sharing it with me. So what are login nodes for, and things that we expect you to do on them? The first, as I demonstrated right at the beginning, is authenticate correctly. This is our portal for users to come in from the outside world, and the internet. Well, it's not the early days of the internet anymore. The internet is a fairly chaotic place. So arriving on a login node is essentially allowing you into a number of much more protected or environment, the networks that exist within the cluster. So things that we expect you to do on login nodes is stage data. In some cases, certain systems have dedicated data staging nodes, because sometimes staging data is actually a substantial computational task in its own right. But compress and uncompress files. So there are some examples of this up on the screen. I trust you can find them yourselves as needed. Read data to and from Corral. So you will find some Corral mount points in the root of the file system. Corral is one of our substantial storage subsystems, and it's our library archival system. So our expectation is that we store curated data sets on Corral, and perhaps you might want to read sets of files from Corral. Corral is generally only available on login nodes. So reading from Corral, and then compilation of software. So our module environments are all set up on the login nodes. It's one of the earlier commands that we will almost certainly have a future session a lot like this one, that discusses the module environment that we have. But the module environment grants people access to all of the software that Tacc staff provide, as well as a fair selection of additional items that you may be interested in. Compiling on login nodes is generally acceptable, although there are some compiles that are fairly substantial in their own right, and in those cases, we would prefer that you move from a login node to a compute node, depending on how substantial your compilation is. The main thing about the login nodes is that the architectures on login nodes should match the architecture on the rest of the cluster. So doing your compilation there should get you a match to the CPU that your job should actually execute on. In the case of Stampede, that's actually not quite true, because Stampede has got 3 architectures in it. It's got KNL processes, it's got Skylake processes, and it's got Isolate processes. So there are cases where, again, this, we expect you to do compiles on the login nodes, but there's a slight asterisk with that. So depending on the requirements of the compilation and also the matching of the architecture. So the question being, if you would like to start exploring what other options you have, we start looking at some of the basics of the queues. So this is the first query to the scheduler command that I'm about to run. And you can see this is a fairly substantial amount of output. There are a huge number of abbreviations and shortcuts to sinfo that can reduce the output of the text substantially. Unfortunately, the syntax is somewhat arcane, and I don't know it off the top of my head. But you can see some of the various architectures are prefixed in queue names. So if you need your compilation to match a specific architecture, you can go to one of the nodes that has that architecture and run your compilation from there. So this brings me to the next item that we expect, and is kind of the most obvious from the concept of a login node, is launch jobs. So Tacc has got a very convenient tool called idev, which will allow you to launch a very basic job, kind of the simplest, easiest job. Many people implement this in the form of a sleep job. idev is a fair bit more advanced than that, but many admins and many users of these systems will have a very basic sleep job, as you can see from my personal node. So directory. We can take a quick look over sleep job. So essentially just putting entries into the selecting a queue, some input and output files. I'm pretty sure there will be another one of these events where we discuss basic job submission, but I'm going to go ahead and demonstrate an idev job, which is fairly similar to a sleep job. So the first thing that will happen is a summary will be produced of what idev thinks my defaults are. And at some point in time, having selected a series of defaults, I will arrive on a compute node. So the difference between login nodes and compute nodes is that we are in a position on a login node, we're in a shared environment, as I demonstrated when I listed all of the other users sharing that login node with you, being a user who's just arrived on a login node. I am now on a node that is dedicated to myself. Having logged into our system for the first time, keep in mind, login nodes are a shared environment, and they are effectively a free space for you to work on staging and setting up your jobs. There are some things that we require you not to do on login nodes. So specifically, the main one is run anything on the login nodes that is related to your actual workload and your actual job that you need to be completed. So anything staging and preparation is probably fair game within reason. Anything that effectively should be paid for by your allocation, you need to move to a compute node to execute those workloads. So any MPI related jobs, anything that takes most of the cores on a login node, we're watching for those scenarios, and those can't be run on login nodes. There are a couple of other things that occurred when we first logged into the system, and I am going to rerun a command if I can find it. Stampede is a little bit of a, I might actually just relog in and find it because I don't remember where it's located. We produce a short summary on login, which I would like to discuss briefly. So this is the output of a command called TACCinfo. I can't remember the location of TACCinfo. It's not in the original path, but it gets run during the setup of your shell and your environment. And it's worth just going through some of the items. Once again, all of this is in the user guide, and I realize I'm running out of time, or either have run out of time, but I'm going to continue anyway. And if that's a huge problem, I'm sure that someone will cut me off. Project balances, this kind of goes back to exactly what I was saying about the concept that anything for your main workload should be run on a compute node, and anything staging and preparation can be run on a login node if necessary. But your allocation is essentially the amount of service units that you've been granted on, in this case, Stampede. And if you're not spending those service units, well, effectively, Tacc is not being quote unquote paid for the computation time that you're spending with us. So we obviously have to report our metrics, and when you spend service units on valuable science, that's beneficial to Tacc. So the project balances will exist for your own account. If you have more than one project balance, there are a few things with IDEV and sleep jobs that become a requirement. It's very easy to pick a default when there's only one entry. It gets a little harder to pick a default when there's more than one. You'll see in the case of my account, I have more than one project and an allocation in each, and I will have used an IDEV trick to force myself to select a default IDEV project, which is why it didn't prompt me for a default. The next item is file systems. So you've got 3 file systems available to you on Stampede, and some of those have got quotas, and they all have a selection of different rules. So storage hierarchies are important to most people who work with computing in any way, shape, or form. Many of you will have a drive in your personal laptop, a Google Drive or Box or other shared environment, and possibly more of those provided by your employer or other scenarios like that. And they all have different tiering rules and different expectations from them. And supercomputers are no exception. So your home file system has got a 10 gigabyte limit, and also a limit in total count of files that you're allowed to host there. And the home file system is backed up. So this is a place to store very small amounts of data, and in a reasonably safe and redundant way. And it is a very low performance file system, so we would expect you not to launch any jobs from home one. The work file system is also available to you, and this is what we refer to as our globally shared file system. The globally shared file system is a file system that is available on all of Tacc's clusters. So if I was to move to Frontera or Lone Star 6, for example, I would find all of the same files. It is mounted consistently. It is what we call a shared namespace. So one of the best ways to view that is if I go and look in my own work file system under nthorne. This is my location. There are a selection of directories, and these are all systems that I have had accounts on at various times or currently have accounts on. So I can find my files from Lone Star, which is actually Lone Star 5. It's a little bit of an issue with naming. Back in the Lone Star 5 days, it turns out I have no files in that case, in that specific location. But those would be my Lone Star 5 files. Finally, the Scratch file system. So this is where we provide you with a file system that has no limit whatsoever in terms of a capacity of data, and it has the highest performance of any file system on Stampede. So Scratch, as the name implies, is for fairly temporary data, and there is a situation where you will see that Scratch is currently 85% full at the moment, and we make an effort to clean Scratch on occasion. So there are a selection of policies in place, and you should go and read about these in the user guide. But essentially, the only way we can provide a file system with no limit for all users simultaneously is if either the users clean up after themselves or we clean up after them. So there is a purge process that is implemented on Scratch, and it's not something that's particularly pleasant, but as file systems fill up, the performance gets worse the closer to 90% or above 90% that you get. And so, and in addition to that, we cannot have the system run out of space in its entirety. Otherwise, nobody would be able to write any data any further. So these are the three file systems, and they need to be used appropriately at all times. So home directory is a location for you to just pull down files from the internet, git clone software, run some basic build tasks. But as soon as you start to execute jobs and store data files, you're probably going to want to store them in Scratch. And you have to have an expectation that while they are not being actively used for a period of multiple days, usually over a period over months, there's a potential that they might not be there when you go looking for them again later, because we've got thousands of users on Stampede, and they're all consuming space on Scratch in an unlimited way. And work gives you a terabyte of storage that we guarantee will not be purged. So a terabyte of sort of cloud storage where you can store data. So I think those are the main things that you will discover immediately upon landing on a login node. They're all worth reading about. They're all worth reading about in the user guide as well. And I apologize for running over time, but I think that's the basics of things that we want to discover. I did note that there is one question, and I'm actually going to go and hunt for you for my command quickly that is a far better summary of the sinfo command. I told you that the syntax is somewhat arcane. This is a far preferable mode. Everybody's kind of got a cheat sheet on what they want to get out of sinfo. This is a lot cleaner output without showing you every entry for every node. So you've got a selection of queues. Development is where IDEV jobs will go by default. These are all short jobs. Around, I think, 2 hours is the maximum you can claim in development queues. And then the architectures are all prefixed on the front of queue names. So SKX is Skylake, ICX is Ice Lake, and everything else, essentially normal, is KNL. You can start seeing some of the node counts that you've got available. So there's 1,500 KNL nodes, of which basically all but 7 are allocated right now. So allocated, idle, forget what the O stands for, and total. Any other questions?
Doesn't seem so. Thank you, Nick.
Thanks very much, everybody.
Thank you, Nick.